Hello and welcome to another free code session. My name is Jason Bach and today is Father's Day. So I've had a really good Father's Day so far and not much left of the day, but hopefully the rest of the day goes fine. Got breakfast in bed, which is a tradition in our family for both Father's Day and Mother's Day. And when it's Mother's Day or Father's Day, we get the day off, can do whatever we want, just have at it, feel free to have some freedom. So that was nice. We actually got some rain today, a fair amount of it, which is nice because we haven't had any in a while. We're very little of it, and it's been getting really, really dry around here. So that should definitely help. So cool all around. So what I'm going to do is, I also figured out this project I keep talking about. I think I may have said it in the last recording I did, but I am going to be doing that in a week, I believe. I will be blasting through that and recording it and doing all sorts of fun things. But what I'm going to do right now is just some other things on the list. And one of them is to test out an idea I have for Transpire, which is this in the analyzer, which is I am getting the GUID symbol here on every operation. And so what I'm wondering is, can I do this such that I cache that, maybe put that in a lazy, maybe I just put that in a static read-only field, because reasons I'm going to want to have this called all the time, or when this does get called and loaded, the odds are you will probably have this fired because you will be doing object creation in your code, although that's not a guarantee. But the point is, think of some caching mechanism so that, like I'm doing up here with rule, but I don't want to necessarily make it unless I absolutely know I need to do it. So the idea is, does it help if I don't actually do this every single time? Now, the other thing I don't necessarily know, and I guess I could look this up, is this. Is the analyzer cached itself? So if I say C# analyzer caching, not catching, caching. No, I don't see. This is where it's going to be like, oh, caching. That's not what I'm getting at. What I'm getting at is the diagnostic analyzer itself cached? But even in that case, it did copy that, right? Okay. One other thing. Yeah. Error overloading. Would not surprise me in the least bit. That's actually really, really sad. I don't know why it's doing that right now. What is the task manager setting at? It's really slow, whatever it is. 73%. What's pegging it? System interrupts. Well, of course. Well, OBS is, but that really shouldn't be that big of a deal. So you notice it's Visual Studio 2022 preview, and there's 2 of them running. I'm doing this on purpose because I want to see how this is and how it works. But unfortunately, it seems to be like OBS is really, really struggling right now. And it's not just OBS, it's other things. But OBS really seems to be hurting. 64-bit Windows. I don't know. So this is kind of a guess, and this may be a complete disaster because, Visual Studio 2022 is not. I've heard good things about it so far online, and people are saying that they really, really like it. Even giving it as a preview. So I figured, well, let's do this episode and try it out, and see how it goes as a 64-bit app. So far, having this error overloading is not a encouraging sign, and that has anything to do with Visual Studio, but who knows? Anyway, I mean, my fan is, I can hear it. It's really, going hard, and it's because of just how hard the CPU is being pegged. But But again, it looks like runtime optimization service. Why would that? I have no idea what that is. Like DCF wins. What is, well, OBS goes back again. What is that? Oh, you can just go away. Jeez. Not that that's going to help much, but hopefully that kicks in a little bit more. Maybe, sort of, kind of. So, anyway, so I'm going to do this in 2022 and just see how this works and how this goes. So again, even if the analyzer is cached itself, we don't want to do this because this method is going to get called essentially every time you hit a new operation. And even if that was a static method, point is we should cache this, okay? Or at least look into doing that. And I think I already had here, oh, wait a minute. No, I have that issue already there. Okay, let's close that out. Let's pull this over here, and it's number 3. Okay, so let's go here and go get new branch 3, do perf work. Okay. And this is also just to see if this is, because I think this comes up in other things that I do, and I want to see, is it worth doing it this way? Okay. So what we're going to do, first of all, is we're going to add in, and of course, since this is a preview and a whole new instance of Visual Studio, some of my preferences of choices aren't necessarily there, but that's okay. So we're going to say add, that took a while. So part of it's, I mean, I literally just installed it, and I would not be surprised if it is slow, if it's clunky, if it's not 100% polished. Not that, quite frankly, it is. I mean, Visual Studio, if I step back for a moment, I think of all the work that's done into it, it is, an impressive tool, but there are moments where I get a little Transpire test performance, okay? No, I do not want to target. Well, why are you? So you're forcing me to use 6, but that's not what I want. I want to use 5. I don't want to move to 6 just yet. So hold your horses. Okay. Come on. No. Man, this is really slow. I'm not impressed out of the gate so far. I have to say that. Okay, and then this toolbar has to go, which I thought I told it already to go away, but whatever. Okay. Yep. Okay. So we already have, that in there. So let's just do this. Let's say investigate caching. Now, at the end of the day, what's probably going to happen is this project is not going to have anything when I commit it, because I'm going to just see what I want and then decide to either keep it or not. If that made sense. This is just brutally slow. This is not the win I thought it would be. Yeah, it's just like, oh my God. Oh, well, can't win them all, I guess. I mean, I'm typing and it literally takes like a second or two before it shows up. That's not what I would hope for. I accept. Okay. So we're going to turn that off. And you need to undock. Come on. Okay, so here's the thing. First of all, we're going to come back into Transpire and we're going to say a copy of this with caching analyzer. Okay, copy the name. Yes, I know. Yes, I know. And yes, I know. And yes, I know. Okay. That should get all the really errors. Now what I want to have is a private static lazy of a iMethod symbol. GUID symbol. Well, we don't, it's not the GUID symbol, it's the GUID constructor symbol, which is equal to a new lazy. Well, it's new, and then we can say, well, it's a func of something. The problem is that we need to get the context into it. Yeah, that's the problem with the lazy, is that there's, I would like to be able to say you have to take a parameter to get the value, but I can't. Just that value factory lazy, yeah, thread safe, yeah. So unfortunately, that's not the way to do it. Okay, and this is also not going to be ideal either, in that it's not going to be set until the first time we come in here, and then we could potentially get into locking problems, which is, or race conditions. But in this case, I don't think it's going to be that big of a deal. So like we could say here, find new GUID. GUID is not null. Well, shoot, we can't do that because we can't assign it and then do that in a ternary. Yeah, we will figure this out. Avoid storing per compilation data of type into the fields of a diagnostic analyzer. I understand you probably why you're saying that, but this is something that should never change. So I get the concern around it, but let's do this. If is null, and yes, I totally understand the problems with this. Equals, and then we're going to say it's this. That. And then we don't need this anymore. And we just say that. So then the only thing we do when we come in is that if it's not null, then we're okay. And now I got to ignore this. Suppress in source. Okay. Compilation data into the field. Yeah, if I take that off and I come back down to the error here, is it actually going to jump into something that's going to tell me something that's of any worth? No, you're just going to do a search again. God. Instance of a diagnostic analyzer might outlive the lifetime of a compilation. Let me see. It's an FXCOP rule. Well, that's interesting. How would an FXCOP actually have this? Okay. Instance of a diagnostic analyzer, hence storing per compilation data such as symbols into the field that cause stale compilations to stay alive and cause memory leaks. Instead, you should store this data on a separate type instantiated in a compilation start action, registered using analyst. An instance of this type will be created per compilation, and it won't outlive compilation's lifetime, hence avoiding memory leaks. Oh. Well, ain't that interesting? I think what this is saying is that if I remember, like if I do GUID constructor symbol constructed from a method symbol, I'm wondering if it actually, the thing underneath the scenes is referencing back the compilation. And so every time you come in, if you're doing a compilation, that's causing a problem. So I get what they're trying to get people to not do. And I mean, it's saying there is also there's a context.register. Well, I think context.register compilation start action. Registers an action to be executed. Compilation start action can register other actions and collect state information we use in diagnostic analysis. But now, yeah. So I think what this is saying is before this one would fire, this one would, and that's per compilation. So if you had multiple object creations within a compilation and you wanted to check, then you could load a method symbol there, stored in a field that's at instance level, and then operation actions, all those would be called. I mean, that's what I believe this is saying, is compilation start action. Yeah. And then there's compilation action for a complete. Yeah. So once the compilation is done, this should say the compilation end action. It feels like that's a little, but in any event, so if you wanted to like grab the contents of something within a compilation, then do this. Yeah, I'm sorry. I can't even talk. You want to grab something in the compilation that was related just to that compilation. Okay. You want to use this. That makes sense. In this case, I'm trying to say, well, a GUID's constructor really shouldn't be anything. Like this should be one and done. I really should never have more than one GUID constructor symbol. Now, again, I might not be understanding the semantics around what this is saying. So I could be totally wrong on this, and that would be perfectly fine. Okay. But anyway, I want to move on because I want to see if this actually does anything of value and or merit. Okay. So what I want to do is something like, if I go to my actual tests here and do a test that does something like, well, I'm going to have to copy and paste some code here, unfortunately. But I don't think this has any, like if I go to investigate caching here and I just, no, not there. Okay, now if I say add missing usings, well, yeah, it's not going to, we could say string source diagnostic analyzer, and pass that in, and then we wouldn't be having to do this, which isn't a big deal, but that way. Okay, and then we need link for reasons. Okay. All right, so then what we can have here is a benchmark where this is the baseline. Okay, true. And we're going to say public int get diagnostic count. Okay, except we need to be async task of int, and because of reasons we need to say async. Okay. Okay, and so what this is going to do is something like a test here that we know we get a diagnostic, which is something like this. Okay, so we're going to pass in code like this. Okay, And we're going to say await investigate caching, investigate, get diagnostics async, passing in this text, giving a new find new GUID. Oh, because we don't reference that. Okay. Hold on. Hold on. So we need to reference the project group. Okay. So if we go to the performance and we reference the project like that. Okay. So now if I say yes. Okay, that. And those are going to give me all the diagnostics. Okay. As an array. And I want to say, oh yeah, I got to, no, not there. Length. There. And now this should say, use expression body for members. So that looks really ugly. And now what we're going to do is another one that should not have that, or that. So this, and oh my God. Async with caching, except this one's going to be a different one. There. And that's it. And then we say here in the program, benchmark runner dot run. Okay. Investigate. Yes. Oh yeah, it doesn't, because it doesn't know the namespace. Okay. But that should be it. And then we need to be sure that we're in release. Okay. So same code in both cases, different analyzer. Is there any difference in memory or allocation or anything like that? So I'm going to pause recording and I'm going to make sure that this is actually the startup. Okay. Run this and see if we get any difference in answers. All right. So I will be back in a moment. Okay. I realized something, which is what I want to get is a compilation without analyzers. And then this should actually just get the compilation with an analyzer and then get the diagnostics. Okay. Well, no, I can't. Never mind. Never mind. I can't do that. You know why I can't do that? Because the syntax tree here, well, no, that gets into the compilation. Okay. And then the references, well, the syntax and the references, those would both give for the same thing. It's just in one case I want to, yeah, okay. So there's something called GlobalState, right, in benchmark.net GlobalState, isn't there, or something like that? Global startup, global setup. Okay, so you can put something executed once per each end value. Okay. Method, which is marked by the global actually once per benchmarked method after initialization of benchmark before all the benchmark method invocations. Okay, so what I think I want to do is, because what happened was it was too noisy. I couldn't really see any difference between the two, and I want to narrow it down a little bit. So what I want this to be is parsecs. This would not be, this will give me a compilation. Get compilation. Okay, we just need the source. Okay. And so what we're going to do here is cut it off right at that point. Okay. And then we'll take that out as well. And return this. Because this should create a C# and that. Okay. There we go. So we want a private C# compilation. Yeah, I've noticed the tabbing with the names is kind of interesting. Unfortunately, it's not going to be able to notice here global setup. And then they say, yeah, we'll just call it that name. That's fine. And we'll say this dot compilation. Oh wait, no, we can't. Oh yes, we can. That's what we want to do. Is we want to say this dot compilation is equal to investigate caching dot. Yep, passing in this text. This is going to be the same for both of them. Okay. And yes, expression body for members. So now we should have this compilation always set. Now what we want to do is change this so that what we have here is a compilation, and this can no longer be static. So if our compilation is equal to this dot compilation, and we know that compilation bang dot with analyzers. Okay, so basically, if I do this, I don't know if this is really going to help, but that. Okay. So then we say here, and we don't have the source anymore. Okay. So up here now, we have this is this. This is this. But this no longer takes the parameter. Okay. There. Okay, so hopefully a little bit better. So I'm going to run it again, and we're going to see if this helped at all, and give us something that's a little bit more meaningful in terms of data. All right, so run again, and I will be back. Okay, so these are the results, and a little promising. I wish the allocated would give me a. What I really wish is that if there was like an allocated to give you a baseline of the allocated memory between the two, but you know, neither here nor there. It does seem like it's a little bit quicker. We basically, what's the math on here? So it's taking 2.17. This is 1.65. So it is a little quicker to actually run the analyzer, and it takes, well, this is 95 kilobytes to 94 kilobytes. That's still a little bit too noisy to really see if there's going to be any significant difference between the two, but it definitely seems to be a little bit better. So I think I'm going to make that the default from this point on. Again, I think I get the understanding between that diagnostic warning or error there, and I don't want to dismiss it. I just think, again, for what I'm trying to cache there is I'm trying to cache the GUIDs, the GUIDs constructor, and that's not going to change per compilation. I just want a symbol for that, and I am done. So hopefully that won't be that that big of a deal. So, you know, and if you do more of these, you know, actually I'm gonna do one more test. Okay, we're gonna do one more test. And the test that I want to do is, where do we go here? If I go back here and I say something ridiculous like var ID is equal to this, var ID 2 is equal to this, var I 3, everything should be 0 based, right? 1, and we'll do one more of these, okay? And so the point is that now you've got 4 operations of an object creation going on. And so does that make any difference or not? So one more time, I'm going to run this and see if this actually does change things a little bit. All right. Okay. As you can see here, it's kind of interesting because the ratio between the two actually gets very close. It's still a little bit faster, but that's funny with the caching, it actually starts to get caught up with the diagnostic count. And I would imagine that's because you're calling it more often. So this is getting to be even more of an investigation, because it's like, okay, what happens if you threw like a real piece of, excuse me, something caught in my throat. What if you gave this a real piece of code and a real application where you would have something like, you know, a whole class, and you'd have a whole bunch of code in there, but you only have like 2 operations, and what happens then? You know, there's I think a lot of different ways to look at this. The nice thing about it is that it does seem like it keeps the memory slightly lower because you're not allocating that GUID constructor symbol all the time. And it does seem to be slightly faster, even though the ratio doesn't really give you a whole lot of confidence to say that it's, significantly faster. It's better here, not so much here. I'm wondering if, if I kept playing with this, if I started doing like more and more constructors in the code and what that would look like. So who knows? That might be for another time. But again, this is Father's Day, and I don't want to get too bogged down on stuff. So to me, though, it seems like it makes sense to cache that symbol. And so what I will be doing later on tonight or something like that is committing this branch with that symbol being cached. And that might be the wrong thing, but that's again, what is, I don't know how many times I said this. That's what's so nice about Benchmark, is that it really didn't take that much to set up a scenario, set up a test, and go, hey, what is the difference between these two? And if I didn't even want to put these analyzers in there, I could have just copy and pasted them into the benchmark and done it that way. That would have been perfectly fine. And just see what is the difference between these two approaches. And, does it make any difference? So, that's kind of nice. And you could also say down here too, like, support diagnostics. I don't even think that was being called in what I was doing, but well, no, that should be doing one and done, because it's basically saying this is a yeah. Okay. Never mind. Probably. Okay. But in this case with that symbol, I think caching it makes sense, and using benchmark.net makes this relatively simple to get some answers and do some reasonable analysis and conclusions. So that's all for today and for this episode. So thank you all for watching. Leave some comments and questions below. See you in the next episode.